Hello everyone and welcome to this video. In this video I'm going to cover PWM. And PWM stands for Pulse Width Modulation. Right, so I don't know if you remember, but in one of my previous videos I controlled a fan, this fan here. I controlled a transistor which turned it on or off. And basically what the Arduino did is it turned a transistor on or off using digital write. So you can either use digital write low or digital write high. Digital write high is 5 volts and digital write low is 0 volts. And of course the Arduino is digital. It can output either high or low, 5 volts or 0 volts, on or off, etc. It's Boolean, basically. It can either be 0 or 1, true or false, etc. There's only 2 states it can be. Usually we call them low and high, or high and low. So the problem with this is that you can't actually output anything in the middle. So if we want to turn something on, that's fine, we can output high. If we want to turn something off, we can output low, and that's fine. But what if we want to output, say, 3.3 volts? Or what if we want to output 1.66 volts? Or what if we want to output something else in between? Well, the answer is you can't. It's digital. You can only output 0 or 5, and that's all. That's everything. That's all you can do. So, of course, that presents issues. There are lots of devices which need to be able to output or receive these analog values as an input. So how can we do that? Well, specifically I'm going to cover outputs. So let's say, for example, we try to control this fan again, or another device, but you wanted to control the speed or the voltage. Let's say we want it to run slowly. We want it to be controlled by, say, 1.66 volts. Maybe we'd have another setting to make it a bit faster, and then there's full speed here, and of course 0 will be off. How can we do that using the Arduino? Well, by default, you can't. So what we have to do is we have to use something clever called PWM, Pulse Width Modulation. And the way this works is like this. Let's say we want to output 5 volts constant, so we output high, okay? If we want to output 0 volts or off, we can output low. Now, if we wanted to output an equivalent of 2.5 volts, which is of course half, then what we would do is we output high for an amount of time, and then output low for an equivalent amount of time. So if we say that's 1 millisecond, we'd output 5 for 1 millisecond, and then we'll output 0 for 1 millisecond. 0 volts, 5 volts, 0 volts. And basically, when you repeat this very, very fast, you can get it to sort of appear as though it is 2.5 volts. So if we carry on with that, and if we did this, let's say, I'll just use a different piece of paper. If we did this, so we've got high, and then low, and then high, and then low, and each of these are 1 millisecond gaps, let's say, that could equate to 2.5 volts if you average it out. So if you use equal spacing and you have high and low, that will be a 50% duty cycle. And that means basically that the resultant voltage, when averaged, would be 50% of the high value, which in this case should be 5 volts. So this would equal, when you average it out, it would equal 2.5 volts. The important thing is, of course, when averaged. So now, what if we did this? So we'll do high, then low, 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 high, low, low, low. What would happen here? Well, this is 25% duty cycle. It's on 25% of the time, so 25%. I'll call it duty cycle. In fact, DC is not a clever thing to do here for obviously direct current. It's duty cycle. Well, if that's 5 volts there, and we're outputting 5 volts for 25% of the time, and of course 0 volts for 75% of the time, then it makes sense for this to be 25% of that, which I believe is 1.25, is it? 1.25, let's just work that out, 4, 5, yeah, 1.25 volts. And if you did, I don't know, let's say we did an eighth, so we've got a high, then 1, 2, 3, 4, 5, 6, 7, high, 1, 2, 3, 4, 5, 6, 7, well, that would be a 12.5% duty cycle. And 12.5% would be half of that, which should be, is it 0.75, something like that? 72, something like 0.72 volts. And that's the way PWM works. So it's a percentage of time when 5 volts is high, and a percentage of time when it's low, 0 volts. And basically, this is pushed together. It's done really fast, and the resultant output is what I've just described. So in this case, it will be that. In this case, it will be that, and in this case, it will be that. Okay, I'm going to prove this to you now. So I'll just
So this is very, very easy thanks to the community or the contributors of Arduino. They've created this function called analog write. So I've used analog write. The first parameter is the pin, and of course I'm using pin 10. The second parameter is a number from 0 to 255, and the number from 0 to 255 represents the fraction, if you like, of the 5 volt output. So in this case, I've just typed in number 128, which resembles half duty cycle, 50% duty cycle, which means that 50% of the time the value will be 5 volts, and 50% of the time the value will be 0 volts. So yeah, basically output 5 volts for half the time. 128. So I'll upload this now, and when this is uploaded I'll show you the oscilloscope. Okay, so it's uploaded, so I'll show you the result on the oscilloscope now.
Okay, so you can see here that the resultant output is that it's outputting 5 volts for 1 millisecond and 0 volts for 1 millisecond, and that's repeating. And the interesting thing is, if I look at my voltmeter here, you can see that it says 2.29 volts, which is about half of 5 volts. So I'll go back to the sketch and I'll change the number to be something else. I'll change the number to be, instead of 128, I'll change it to 64. 64 should be a 25% duty cycle, which is about 1.25 volts. So we'll see. Okay, and you can see here that it is a 25% duty cycle. You can see here that it's on for 25% of the time, and 0 volts for 75% of the time. And looking at the voltmeter, you can see that it is 1.15 volts. So what if I change this now to something else? I'll change it to 192. So 192 would be 75% duty cycle, which would mean that 5 volts is on for 75% of the time, and 0 volts is 25% of the time. And the resultant output should be that it's 3.75 volts. And you can see that it's actually 3.44 volts, which that's good enough. So yeah, PWM can have many uses, and like I said earlier about a fan, it could actually let you control a fan speed. So instead of being able to switch things on or switch things off, it lets you kind of emulate analog outputs, and that can be very useful for certain projects. So that's PWM in a nutshell. I'll do another video soon demonstrating how you can use PWM practically. It will probably involve controlling a fan or the speed of the fan. So stay tuned, and once again, thank you for watching. Bye.